Hi, my name is Karima Yamile Arias de la Cruz, and this is my explanation of the first argumentative examination. So let's start. Well, first of all, we will start with the problem one, where we have to help Captain Ralph by answering the following questions. The first one is in which direction he has to advance in order to decrease the temperature of the spaceship hold as quickly as possible. Well, first of all, they are giving us a function, but as we want to get away of a point, we have to calculate the gradient. This we calculated with the partial derivative of each variable. So we calculate the partial derivative of x, the partial derivative of y, and the partial derivative of z, and we substitute. Well, we use like that in our directions. And then we have, as we want to know the direction in order to decrease, we have to, well, this has to be in a negative way. So we have to multiply the direction that we have times the minus. So this gives us this result, and this is our direction. But we have to evaluate it in the point 1, 1, 1, as the instruction says. And we substitute x, y, z, and this gives us this result, that is the gradient in 1, 1, 1, or we can factorize it. Well, this gives us this result. So this is the result of the first one. We have to grab the point in GeoGebra and also grab the corresponding direction starting at point. Okay, I will do a zoom. So this is where the spaceship is at first, but as ordered, we want to decrease the temperature, the direction will decrease too. And this is the direction that the spaceship has to go to decrease in order to decrease the temperature. And well, this is how I made it in GeoGebra. And well, then we will go to the number 2, that is if the spaceship travels at the speed of e at the power of 8, what is the speed at which the temperature decreases if he travels along the direction of the previous question? Well, they've given us the speed, and they tell us that we have to use the direction of the previous question, that is the gradient. So we have to do the directional derivative, and well, this is the formula, and then we have to do the norm. Well, we have to get the result of the norm of the gradient, and also we substitute that the formula, and it's this result, and then we have to multiply the norm of the gradient times the speed, and this gives us this result, that is our speed at that is our final speed, that is minus 74.2591 meters divided by seconds. And well, as the speed is a vector, it has a lot of sense because it is decreasing. It's a negative because it's going in that direction. So it's the same as we are telling in the first exercise and in GeoGebra too. Well, then is the problem 2, where they are telling us that we have to calculate the volume of the water. So here we have to use the theorem of the model for the volume functions. And well, we use the function, well, the model, and then we have to integrate with respect to y. We integrate with respect to y, and this is giving us our first constant. Then we have to integrate with respect with x, and then it giving us the second constant. And well, we have to evaluate that constant in 0, 0 in order that we can eliminate both constants. And then our final function of the volume is this one. So we have to first evaluate in the lower point, that is 0 in this rule, that it's 0, but the speed will be, well, sorry, the volume, it will be 0. And well, then we have to evaluate in 4, that is our maximum point, and we have to evaluate the volume in 4, 4. We substitute at the formula, we do the operations, and then we have that the volume in 4, 4 is 64 meters at the power of 3. And this is our final result and my explanation of the argumentative examination. Thank you for your attention, teacher. Bye.